All right, here is the Chapter 6 practice test. We're going to go through it. Question number 1 and question number 2 are from section 6.1, and the answers are really straightforward. You're just taking the square root and cube root. Everything works out perfectly in section 6.1. So the square root of 64 is 8, and the index for square root is 2. And remember, you take the index and divide it into the exponents. You're essentially cutting the exponents in half. So it's x to the fourth and y to the second power. So it's the whole EIEIO thing. We got the exponent divided by the index. So the exponent is 4 and the index is 2. So that yields 2. The exponent is 8, the index is 2. So that yields 4. So the correct answer is 8x to the fourth, y to the second. Just like we did before, you look on your colored paper, you look for the cube root of 343, and that's 7. And then you take the index and you're dividing it into the exponent, and it's z to the fourth power. Next row, this is where things don't necessarily work out perfectly. They do work out perfectly on number 4, though. If you multiply these two together, you would get 400. And then when you multiply like bases, you add the exponents, you get x to the 8th. So then I don't really have to split this up. I can just take the square root like I did in the first question. Square root of 400 is 20, and then you cut the exponent in half, just like number 1, x to the fourth power. Now this one here, you can't take the cube root of these, so you're looking for the largest perfect cube that's a factor of 200 or 648, and that would be 216. So you make your two radicals. 216 divides in there, and it's kind of a, you just kind of go through and try different perfect cubes. You have your list of perfect cubes, and you go through and you say, okay, does 8 divide into there? Well, yeah, 8 divides into 648, but you want the largest one. So eventually you find out that it's that it's 216, and that would be times 3. Then you take the index and you divide it into the exponent. Does it divide? No. So I drop it down 1 power and make it x to the 12th power. And that does divide. And that since I dropped it once, there's 1 x, or x to the first. If you want a 1 there, you can, or not. It doesn't matter. Now I take the cube root of this guy right here on your colored paper. Cube root of 216 is 6. And then I have the index dividing into the exponent, it's x to the fourth power. And then this is the junk left over, cube root of 3x. So there's the answer to that one. All right. Number 5, you have to have like terms in order to be able to add or subtract. I cannot add those together until they are alike. So I have to split it up into what I can take the square root of and what I can't. Quickly going through the list, I find that 16 divides into 80 evenly, and that's a perfect square. You're not allowed to split it up any way you want to. You can't do 8 and 10 because they're not perfect squares. You got to break out a perfect square. So 16 and 5, and then a big clue, these are going to turn out to be the same, so there's a 5 there. And 5 times what? Well, 36, and that would be the largest perfect square that lives inside of 100 and 180. So I get 4 radical 5 and 6 radical 5. So all in all, I have 10 radical 5s. All right, number 6 is foiling. We got first, outside, inside, and last. So it'd be 6 plus 2 radical 5, 3 radical 5, and then the last would be radical 25, which turns into 5 here, because the square root of 25 is 5. So you can make that be 5. You don't even have to write square root of 25. You just know that the same radical times the same radical yields the thing underneath. Okay, so I got 6 and this 5 make 11. And then these are like terms in the middle. 2 things and 3 things make 5 things. So it's 5 radical 5. All right, moving on, checking the time. We are a whopping 5 minutes in. All right, and next page. This is like so easy it's confusing, I think, for people. But basically, it's the EIO thing. So the index is the bottom one, which means I'm taking the fourth root. So the fourth root of 10,000 is 10. And then I do the 3 next, which means I'm raising 10 to the third power. So I get the answer of 1,000. Another way to think about it is what is 10,000? A 10,000 is 10 times 10 times 10 times 10. So I threw all the tens into a multiplication bucket there. So 10 times 10 times 10 times 10 makes 10,000, and I want 3/4 of those tens. So if I do 3/4 of the tens, that means I have 1, 2, 3/4 of them. So I have 3 tens that are being multiplied together, which is 1,000. So that's just a visual kind of way to think about it. Okay, radical form, EIO. There's the index. There is the exponent. Boom, done. All right, now we're solving these four. The first one is super easy. I square each side. I get x is 25. The next one, I do regular algebra first. I get 3x minus 2 is equal to the 3/4 power, and then I get 8. So you always do as much regular basic algebra as you can, and then you do the special thing. Well, the special thing is to do this exponent backwards. So the 4 is the index. I'm going to now make it the exponent, and 3 is the exponent. That becomes the index. So essentially the fraction flips upside down. And when you have a power raised to a power, you multiply. So it's 3 times 4 is 12, and 3 times 4 is 12, and 12 twelfths is 1. So the exponent cancels out. So I'm left with 3x minus 2 is equal to, the 3 here means cube root. Cube root of 8 is 2. 2 to the 4th power, do this second. So first and then second. So that would be 16. Now I solve back to solving regular algebra problems. So add 2 to get 18. So 3x is equal to 18. Kind of poor planning on my part here. Running out of space. And x equals 6. All right, the next one, I have squares on each side. Just do the opposite. There's no algebra, basic algebra I can do first, so I square each side, leaving 4x minus 2 is equal to x plus 10. Now I got to get the variables on one side, numbers on the other. So I'm going to subtract over the x. Gives me 3x minus 2. Just this is all basic algebra 1 stuff. Add 2 to each side. Just solving away. 3x is equal to 12. And finally, I get x is equal to, divided by 3, 4. All right. And basically, for all these, you want to make sure that the answer works because you're changing it into a new kind of equation. So number 9, if you put 25 back in, that would definitely give you 5. If you take the 6 and put it back in, that give you 18 minus 2 is 16. 16 to the 3/4 power is 8, and then 8 times 5 is 40. And this one here, if I put the 4 back in, I would get the square root of 14, and then 4 times 10 is also 14. So it does work. Now in this next one, we have to check for extraneous solutions as well, and this actually does produce one. All right, so I square each side. I have the square root of x plus 7, and then that gets squared, and then equals x minus 5 squared. And we do not want to square this wrong. When you square the square root, the thing underneath falls out. And when you square a binomial, you have to write it down twice. That's like the pet peeve of math teachers is when people don't do that and they say the answer is x squared plus 25. No, you must FOIL. First, outside, inside, and last. So I get x squared minus 10x plus 25 is equal to x plus 7. All right, I'm going to now solve this quadratic. When you solve a quadratic, you have to set it equal to 0. So I'm going to subtract x on each side, and I'm going to subtract the 7 over. That gives me x squared minus 11x plus 18 is equal to 0. So the first thing that pops to mind is 2 and 9. And 2 and 9 is awesome because it makes 18. Whoops, it's going to be double negative. 18, and then 2 and 9 make 11. So zero product property, you set each factor equal to 0, and we get x is 2 and x is 9. So now the important thing is to go back and check it into the original problem. Let's go full screen here. Boom, full screen. So if I have to go back to the original, which would kind of, it's right underneath here. So let me do a little cleaning up there. Got to go back to the original with this. You can't put it back in the thing you've squared because that's when you've changed the equation. If I put 9 in, I get 16. The square root of 16 is 4. If I put 9 in the other side, I get 9 minus 5 is 4. So that's okay. So this one's okay. But when I put back 2, it's not going to work because 2 plus 7 is 9, and the square root of 9 is 3. So I got 3 on this side. But when I put 2 here, it's 2 minus 5, which is negative 3. So that's a bad solution. No. I have my colors backwards. I should have red and green switch there, shouldn't I? All right, so that's the second page, which had quite a bit of things on it. Let's do my time check again. And, yeah, we're a little bit over. 5 minutes a page would be awesome, but here we go. This page should be quicker. Okay, when there's a number here, I always think about this first and then this second. So I take 2 to the h function over here. 2 times 3 is 6. So now I'm doing f of 6. The 6 goes to the f equation, so I'm going to square that 6 and get 36. The g5 is going to go to the g, so I'm going to this g function here, which would be 9, h of 9. Now I'm going to take the 9 to the h function, so the answer is 27. 3 times 9 is 27. Now I'm putting functions inside of functions, so when I see this way, I always think about doing this first and that second. So what is the f function about? The f function is about squaring something. So the f function is something squared. Now what am I putting into that f function? The whole h function. And the h function says 3x. So the answer is 9x squared just by squaring that. Then 15 and 17, you just do what it says. It's 2 times the f function. So it's 2, and then we write down the f function, which is x squared, plus 4 times the g function. The g function is x plus 4. Since the g function has 2 parts to it, we have to distribute because you have to multiply each part by 4. So the final answer is 2x squared plus 4x plus 16. You're not solving these, you're just doing what it says to do. And then the next one, it just says to multiply, so we get 3x for h and x plus 4 for g. So then I distribute, and I get 3x squared plus 12x. Boom, done. And that was a pretty fast page. Okay, the last page has the inverse stuff on it, 3 questions. And how do you find the inverse? Well, you have to make the input the output and the output the input. So what you do is you switch x and y, and then we solve for y. Switch x and y, solve for y. So solving for y, I have to subtract 4 over, and then we get x minus 4 is equal to 5y. We divide everything by 5, so we get 1/5 x minus 4/5 equals y. And that would be the opposite of it. So the original function had addition and multiplication, and you can see that the inverse has to do with subtraction and then the dividing by 5. So it is the opposite way. Okay, switch x and y, solve for y. Switch x and y, solve for y. So I'm going to add the 2 over, so I get x plus 2 is equal to y squared. And then I take the square root of each side. Square root, square root. Now when you square root the something that's squared, that yields the plus minus business. So we get plus or minus radical x plus 2 equals y. So the original function had something to do with subtracting and squaring, and you can see the inverse makes sense because it has something to do with addition and square rooting, which are the 2 opposite ideas. Okay, the graphing one, I really threw you a soft toss on this one. I gave you what I wanted you to put in. So if we put in -3, we get 0. So that means you switch and you get 0 -3. Here, I'm going to do this like I did it in class. I'm going to use for the black for the original and then blue for the inverse. So I put in -3, and that gives me 0. I put in -5, which would be -2, and then that gets squared, so that'd be 4. And if I put -1 in, it's going to be -2, also squared, is 4. So there's the original. Then the inverse is the switching of those. So it's 4, -5, 0, -3, and 4, -1. Then I'm going to make my two parabolas, one that's facing up and one that's facing sideways, because it's the inverse. Let's see, 1, 2, 3, and that's -3, 0. -1 up 4, 1, 2, 3, 4, and -5 right there. So there's the original parabola. And that parabola makes sense because it's a parabola that's been shifted over 3 spaces to the left. Now I have my line of symmetry here, and the inverse is going to flip across that. And you'll see that by the markers of 0, -3, 1, 2, 3, 4, -1, which is right there, and 4, -5, which should be right there. 1, 2, 3, 4, 5. When it copied, it was a little crazy. So I think that should be it. And you can see how this flipped across here. So this one flipped to this one, right? This one here flipped to this one down here. And this one flipped to that one. And everything's perfectly symmetrical. All right, well, that ends the test. Hopefully you got something out of this in 17 minutes. So it's pretty short, sweet, to the point. Hopefully you do great on it tomorrow. Little happy Christmas grade boost. Nice, successful test. Hopefully we get lots of A's and B's and boost everybody's grades and spirits before the holidays. See you tomorrow.